All right, so I believe we are recording. Now we're talking about an alignment process. There's several different views of alignment, and the book does a really good job of taking you through that. I'm going to talk about the practical aspects of that in the real world. And when you get into the classroom next week, you're going to be pulling out motors, you're going to be bolting them down, and you're going to be aligning those motors with a shaft in which you're going to set up a belt and a pulley system and a sheave system. And we're going to do that with chains, and we're going to do that with belts. And you guys will learn practically how to do alignment, at least on a small motor system. So alignment is several aspects. The first aspect is what you see in terms of a misalignment in this configuration, where I've got, say, a drive sheave and a, we'll call it a power receiving sheave, which is this shaft is supposed to receive the power from this motor shaft here, which is driving this whole system. And if those shafts are not parallel, right, if those shafts are not parallel, then the shafts are out of alignment. So then, if I pretend that I've just dropped a belt in there, all right, you can see that that belt is going to get a lot of wear on the inside of these two sheaves on the right, and then on the left, it's going to get a different kind of wear. But most of your wear is going to be received on the inside of that misalignment. So if you see a lot of wear on one side of the belt, then it's probably an indication you've got a shaft misalignment. All right, so, and it's on the same side. So how do I fix that? Well, I need to measure carefully center to center on the shaft. So how do we measure center to center? You got to put your eyeball right over that shaft and then lay your ruler right on that. And if you measure outside away from the sheave or the pulley, then you can get a more accurate measurement. Now, a lot of times shafts aren't long enough to get an accurate measurement from shaft center to shaft center. A lot of times you've got a motor sticking into a sheave and only a tiny little nub of that shaft sticking out, or vice versa over here. So what we recommend for rough alignment in those systems is you take your straight edge and you set it on the sheave here, and then you adjust the other sheave, and I'm going to get my little simulated shafts and simulated belt out of the way. And then you get your alignment by making sure you have 4 points of contact with the sheave. And because these sheaves have kind of like, they're made of pressed steel, so they're not flat, completely flat on one side or another. They're actually a little easier if you're talking about a sprocket, which has a flat face to it. But these sheaves have this big old pressed steel concave outside. So you just have to look at 4 points of contact. 1, 2, 3, 4. So if you have a straight edge that's showing you those 4 points of contact, then you know that you're pretty close in terms of alignment. And this is really easy if your pulleys or your sheaves are close together, where you got enough distance so you can lay in a straight edge and be reasonably sure that they're in alignment. But what if they're very far apart? What if they're more than 2 feet apart? Then you'd have a lot of trouble doing that, and that's why you would then use the shaft-to-shaft measurement, which you can put a tape measure on and run a little bit further. Luckily, having very long pulley travel is not very common and actually not very good design from an engineering standpoint. So for the most part, you're going to be able to take a 2-foot or a 3-foot straight edge and do this sort of rough alignment. And that's one thing that you're going to do in class. You're going to be able to put a tape measure on it, or you're going to be able to use a straight edge on it. Now, because I'm using sheaves that are designed for different belt sizes, this alignment does not work at all for this configuration. And that's an important thing to remember. Sometimes the sheaves are of slightly different design. So you need to make sure that the outside edge that you're measuring matches up the equivalent outside edge on both of your shivs. If they're two different designs, you might need to have one of the shivs offset slightly. You add maybe a fraction of an inch to get in a proper alignment. Any questions about this? Well, actually, I'm going to keep recording. I'll open up for questions at the end. So the other alignment is when we've got twist. Say this, let's try to do it this way. This shaft points to the twist is to the left. And now, because I'm showing you one pulley on top of the other, you can see that the shaft closer to you twists to the left. That is a shaft twisting scenario. That means that these are not square to each other. A lot of times you can fix this problem by shimming up your motor mount or adjusting how your power receiving shaft is set up as well. But this becomes another configuration as well. And how do I make sure this is right? Well, I can lay my straight, I can use the sighting method, or I can use the straight edge on top of the shafts to make sure that both the top of the pulley is lined up and the bottom of the pulley is lined up. See that? And those are the two most common out of alignment methodologies. If it's twisted, you're often going to see several corners of the drive belt worn. You'll see it worn on, say, all four corners, because the twist actually creates wear on both sides of the drive belt.